we'll just pause for a minute, try to talk a couple of them out, and answer any questions, and then let you go back to wherever you're working on here. But I'll just kind of talk a couple of them out. Again, I would say 1 is extremely common. I think we've seen it pretty much on every exam. What is the one thing that should be going through your mind here? I hear it so quietly. Split. You definitely have to split this function up. F of x deals with the picture, and 2 does not. Okay, like again, we've seen this on almost every single exam that we've done. So we have to integrate from -2 to 2 of just f of x, and then we have to add on to that -2 to 2 of just 2. Okay, because again, 1 deals with the picture, 1 does not. So -2 to 2, I'm looking for that area. So visually, you're looking for that area. And then you're going to add on, you're going to have to integrate 2 by hand. Okay, so I'm going to try to give you a hint if you're stuck. You're going to go back and work on it. So again, this deals with the picture. Integrate 2 and plug your bounds in. I saw a lot of weird answers on that one. So again, I don't want to just tell you the answer. I want you to go back and work it out if you didn't split. Number 2, I thought was a pretty extremely generous question. Just a simple u sub. When you make your du, though, you do get du equals 3 dx. So you should be getting du over 3. So what do we definitely want to see out front? A 1/3. So again, I'm immediately eliminating those. I know I have a 1/3 out front. And if I do a u sub, what can my bounds not be? The exact same. So u sub should have u bounds. So again, my lower bound should have become a 4. My upper bound should have become a 13. So again, I whittled that down just from knowing my bounds. But I definitely have that du over 3 coming out. 3 was pretty generic. Just rewrite as x to the -2 and integrate if you needed a hint there. 4. So this was the day I wasn't there and I gave you the video for. If this is something you need to go back and watch, I mean, most likely, well, again, like we've done how many practice exams? Like 8 or 9? Have we seen this question once yet? No. So it's a pretty rare question. Is it likely to pop up? I don't know what to tell you. It could pop up. It couldn't pop up. It's definitely not one that we've seen a million times, but you should be able to kind of whittle it down. So again, the number that the width is that b minus a over n. So you definitely need to identify the width. Okay, so I can see that my width is sitting right here. So I know that b minus a over n is equal to 1 over n. Okay, to get the height, it's f of a plus my b minus a over n times k or I or some variable. It doesn't matter what the variable is. Okay, now, keeping in mind that this is the width that I'm staring at here, so this represents the height, I've got a plus 1 plus 2k over n. So I know my a value is a 1. So I'm going to keep that in mind. I know my a value is a 1. And if my b minus a over n is equal to 1 over n, that means my b value would have to be a 2. So I know my a value is a 1 plus my 1 over n times k. And I'm getting this function when I substitute it in. So I can kind of substitute each one in. So I'm finding f of this value. If I substitute it into each of these, I want to see which one I'm going to get. So if I sub 1 plus 1 over n times k into here, do I get this function? I don't think so because that 2 there. So I think I'm going to have something with a 2 to get that. My bounds are going to be 1 apart, it looks like, to get a 1 over n. So I feel like this one's making the most sense because I need 1 plus 1 over n times k. Again, if this is something that feels foreign to you, I wouldn't put all my eggs in one basket on it. It's not something that pops up a lot, but you do have the video at your fingertips to go back and review. Number 5 I definitely, we've talked enough about this. We've seen this on just the last test. If you didn't sketch this out, you probably didn't get it right. Make a nice sketch, draw out the picture, and then find the area. And again, I'm just trying to give you some tips. I can come around and check your groups as a whole. But if you didn't do that, you probably didn't get it. So again, draw the picture out and find the area, any piecewise function. So I'm going to give you a few minutes to clean that up. And then 6 and 7 are extremely nasty. We have not seen those in a while, so feel free to, don't even waste your time. You most likely aren't going to remember how to do those. We really haven't done them in a while. Feel free to skip 6 and 7 and keep kind of chugging through. But I want to just kind of check each group and have a little conversation as you go back and fix anything you might need to in there. All right, I'm going to jump back and talk about 6. So again, this is one we haven't seen in a long time. We did have one person kind of get on the right track with it, which was awesome to see. So obviously, you're going to try a u sub first. You're always trying u sub first in an integral. So if I try u to be x plus 3, its derivative, of course, is just dx, 1 dx. I'm not really getting anything. I'm going to get all that junk, x squared plus 4x plus 5 over u, and nothing's canceling. Okay, so u sub fails, which again means it's somebody special. There's something unique about it. Now again, this is another question. This packet's very unique. This is like our 9th practice test we've taken, and we still haven't seen this question yet. So again, it doesn't pop up a lot, but I'm not saying that it doesn't mean it couldn't pop up. It was obviously, these are all old exam questions, so it did pop up in some time. What this problem is, and it's a good review here, the degree of the numerator is 1 more than the degree of the denominator. And maybe make a note for yourself there. The degree of the numerator is 1 more than the degree of the denominator. So what we have to use in this case is we have to start with long division. And we did spend like one whole day on this earlier in the year. But it is a long division problem. So let's just kind of talk through it together. So I have x plus 3 divided by x squared plus 4x plus 5. Okay, so algebra 2, everyone was really good at long division. You had to be. We're just going to divide those two, see how many times they go in, match them up. Goes in x times, I get x squared plus 3x. Again, I'm just matching those first terms up. I'm saying x times what gets me x squared, which is an x, of course. Multiply that through. And then I subtract. So this becomes a minus, this becomes a minus. Those cancel. 4x minus 3x is just x plus 5. Bring that 5 down, obviously. Then I match this up. How does x become as x? I just multiply by a 1. Carry that through. I get x plus 3. And then again, I subtract the whole row, change the signs, and I get a remainder of 2. So again, we haven't actually done any calculus. We didn't integrate anything. We're just trying to rewrite the form for ourselves. So what we now get is we got a quotient of x plus 1 plus the remainder 2 over the divisor x plus 3. Okay, so this is kind of just your algebra 2 part where you do your long division, you write out your answer. Now you're going to integrate this whole function with respect to x here. Okay, so I'm going to split because obviously one needs a u sub and one doesn't. So I'm going to integrate the x plus 1, and there's bounds, of course, so 0 to 3. And I'm going to split and integrate this fraction because that needs a u sub where that first part didn't. Okay, so I should get that x squared over 2 plus x from 0 to 3. And of course, upper minus lower, so what's that going to get us? 3 squared is 9. 9 halves plus 3 minus, if I plug the 0 in, I get 0. To make my life easier, I'm just going to call 3 6 halves. So I think that gives me 15 halves there, which is nice to see because at least something has 15 halves in it. So again, just from integrating that. And then I'm going to integrate this fraction with my u sub. So u is equal to x plus 3. du is equal to dx. So I have 2 over u du. Okay, and again, I'm just going to pull the 2 out in front. And then I'll have that du over u. So I'm getting 2 every time I have a du over u. That's the ln. I'm I'm going to stick my original back in so I can just use the original bounds from 0 to 3. Otherwise, I would have to get u bounds for the u sub, but I can just put that original back in. Now here's again, once I see an ln, I said, I kind of think, all right, I'm going to have to use some ln properties at some time. So if I plug in my 3, I've got 2, I'm going to go the ln of 6 minus the ln of 3. Again, just upper minus lower. And now just talking through those properties, when I see subtraction in logs, it actually came from division. So this is going to become 2 ln of 2. So I think I get 15 halves plus this 2 ln of 2. Okay? And again, that happens when that degree of the numerator is 1 more than the degree of the denominator. Right? And again, hopefully, if that appears in our exam, you'll see a u sub question, it doesn't work, and then you'll just have to think, last week we did this. Like, try your best on it. Like I said, it obviously doesn't come up much. Now, the second one that doesn't come up much, the other thing we did was number 7. We spent a lot of time on that one. Well, not a lot of time. We spent a day on this one as well. This is not long division because the numerator isn't greater than the denominator. This is actually that complete the square process. So again, another one that hasn't appeared on anything, but I just want to go through it in case it does. So I'm going to make a note. This is your complete the square. Okay, so again, when you complete the square, you take that middle term, you cut it in half, you square it, and then you add and subtract it. So I'm going to take that 6, cut it in half. So again, you do this in Algebra 2. Square it. So 6 divided by 2 is 3. 3 squared is 9. So I'm going to add and subtract 9 right next to each other. So I'm going to say that's x squared plus 6x plus 9 minus 9 plus 13. So it's a way to manipulate the equation without changing the equation, because when you add and subtract 9, you're not really changing the equation. That boils down to a 0. But you're manipulating it so that you can factor it or do whatever you need to it. So you'll notice these 3 terms are always going to be a difference of perfect squares. That's really x plus 3 times x plus 3, or we can call that x plus 3 squared. And then negative 9 plus 13 is going to get me a plus 4. So I'm going to rewrite my integral as 1 over x plus 3 squared plus 4. Okay. Now you might be thinking, like, this didn't actually make my life easier at all. But again, this is just one of these obscure rules. So I want to go over it before we take the exam. So this rule that you're staring at is the rule for arctan, which is du over a squared plus u squared. Okay, and again, we don't do it a ton. It doesn't come up a lot. We just don't do it a lot. All right, so again, just to remind yourself, a is the number, u is the variable. So I have to ask myself, who am I squaring to get each of those? So my u is just the x plus 3. That's obvious. That's the variable squared here. And how about my a? Who am I squaring to get 4? 2. Okay. Now, because you have a u, you also have to do a du. So my du just happens to equal dx, which is nice. I don't have to pull any numbers out. Okay, so I'm going to put it in terms of this. So I have 1 over my x plus 3 was my u, so that's my u squared plus my a squared times my du that we substituted in. And obviously the addition order does not matter. Now what does matter is what this equation is equivalent to. And it's equivalent to, I'm going to stick it over here as well, it's 1 over a arctan u over a plus c. 1 over a arctan u over a plus c. So what I'm going to get here is 1 over a, so which is 1 over 2 arctan, and now it's whatever my u is over my a. Our u was x plus 3 over my a of 2 plus c. Okay. And again, like it's not a common question. It's not something we've practiced 8 million times. They're kind of two obscure questions that hopefully we don't see. But again, I definitely wanted to hit them before the exam in case you do see them, to make sure you are relatively exposed to them. But again, long division is if the numerator is bigger than the denominator, and obviously u sub fails. And then we have this complete the square, where again, u sub obviously failed. 2x plus 6 doesn't cancel with anything when I do a u sub. So not the two friendliest questions by any means. All right, keep going. I think the next set is fairly nice. I don't think there's any surprises for a while. You might see, so we got a good solid 5 minutes here, you might see another long division at some point, so just kind of be aware if u sub fails, but that's okay. Part of the calculator section tomorrow, and then we'll finish up with the final test for our calc in here this week. So just bring this back, okay, work on your spiral, hopefully that's all you have to work on.